Apple released 3 variants of their CPUs in the 14-inch MacBook Pro. How does the 8-core M1 Pro, 10-core M1 Pro, and 10-core M1 Max chips compare to the original M1 in performance and performance per watt? Is Apple's pace of development for its CPUs sufficient to keep up with traditional CPU makers like AMD and Intel? Let's get into it. In my introductory video, I gave my overall impressions of the 14-inch MacBook Pro, but in this video, I will look specifically into the performance of the CPU for the 3 versions that Apple has released and compare them to the original M1. In using these laptops over the past month and doing the comparisons of all 3 of these machines side by side, I found some differences in the CPUs that I didn't anticipate. Starting with Geekbench 5 single-core benchmark, the 8-core M1 Pro scored 1766 in single-core and just under 10,000 in multi-core score, with my highest score at 9983. I just couldn't get it past the 10,000 threshold, but it was consistently in that 9900 range. Compared to the M1 Mac Mini that I have, the single-core score was 0.9% higher. I ran many benchmarks as I did see a difference between these M1 processors. The differences are very slight, but they are consistent. I summarized this in a table where I used the middle score in the 3 runs. Starting with single-core and at the bottom, in last year's M1 Mac Mini, it scored 1745, while the 8-core M1 Pro scored 1766, and the 10-core M1 Pro scored 1773. Finally, the M1 Max consistently scored over 1780 at about 1786. In multi-core, the M1 Mac Mini scored 7689, while the 8-core scored 9945. The 10-core CPU in the M1 Pro scored 12,479, while the M1 Max was 12,746. Again, the M1 Max with the same 10 cores was consistently higher than the M1 Pro by about 2.1%. How do these new CPUs compare to Apple's all-Intel lineup of computers? Using the chart I developed in my previous video that plots all the CPU versions per Intel-based Mac, I'll put a link above and in the description below that walks through the construction of that chart. We can see that in single-core scores, the M1 is clearly the leader against the Intel CPUs, and the M1 Pro and M1 Max chips improve that lead by 1 to 2%. So these new chips are very similar in that they're at least 40% faster than the fastest of the Intel-based Macs. If you are upgrading from any Intel-based Mac, you will surely notice the improved single-core speed. And if you're still using apps that are not optimized for Apple Silicon and have to use Rosetta 2, I also ran the Geekbench 5 benchmark under x64 mode, and even through Rosetta 2, all of the M1 chips are about 8% faster than any of the Intel-based Macs. Very impressive. If we look at the multi-core scores, the M1 bested all the Intel-based laptops and the low-end iMacs, and with the 8-core M1 Pro, it is now better than comparable 10-core Intel iMacs. The 10-core M1 Pro is better than 12 and 14-core Intel Macs, and the slightly higher scoring M1 Max chip gets close to the 18-core iMac Pro. That means the new 10-core M1 Pro and M1 Max CPUs only fall short of the much higher core count Intel CPUs like the 18-core iMac Pro and the 16, 24, and 28-core Mac Pros, and it does this all in a package of a laptop. Running this benchmark under the Rosetta 2 translator, you find that the 8-core M1 Pro performance falls about 20%, or to levels like the native M1 Mac Mini. Also, the 10-core M1 Pro and M1 Max drop to under 10,000 and are similar to the native 8-core M1 Pro. It's just something to be aware of if you are still using software not yet optimized for Apple Silicon. Now let's move on to more CPU-demanding benchmarks. Logic Pro is an application for professional music production. Most people don't realize processing audio is one of the most CPU-demanding tasks that you can have, and since Macs are designed for creators, this is a great benchmark. You can download the benchmark yourself. I'll leave a link in the description. Most people run this test for less than a minute. I ran this test for at least 30 minutes, so that the system was at thermal saturation and you could play this number of tracks all day and all night long. In the table and starting at the bottom, my M1 Mac Mini was able to run 99 tracks before a system overload. The M1 Pro with 8 cores was able to run 131 tracks, while the M1 Pro and M1 Max were able to run 172 tracks. To put this into perspective, I ran this same test in my 12-core Threadripper build, and it was capable to 181 tracks. So the 10-core CPU is almost able to match my 12-core Threadripper build while being housed in a laptop. This is truly amazing performance in this package. Moving on to Cinebench, I ran all M1 CPUs under Cinebench R23, since this benchmark places a much heavier load on the CPU than Geekbench. The single-core score of the M1 Mac Mini was 1523, while the 8-core M1 Pro scored 1530, the 10-core M1 Pro scored 1531, and the 10-core M1 Max scored 1532. In running this single-core benchmark repeatedly, I noticed that the new M1 Pro and M1 Max chips scored consistently around 1530, while the original M1 never scored that high, trust me I tried, and would typically run closer to 1520. This is a slight but consistent difference of just 0.5%. For the multi-core score, the M1 Mac Mini scored 7824, while the 8-core M1 Pro scored 9566, which is 22% faster. The 10-core M1 Pro scored 12,372, and the 10-core M1 Max scored 12,373, which are both 29% faster than the 8-core and 58% faster than the original M1. So these improvements were similar to what we saw in Geekbench. Now, prior to the reviews going live, I calculated an estimate of how these new 8 and 10-core CPUs would perform so that I, along with you, would know what you are getting if you decided to pre-order. My assumption for the single-core score being the same as M1 was more than 0.5% off. Also, my calculated estimate for the multi-core score for the 8-core was 1.5% off, and the 10-core M1 Pro was 1.7% off. With the differences in the benchmarks ending up being higher than the estimates, I started to wonder why. If the M1 cores are all the same, why the difference? So I decided to investigate, and here's what I found. Even though Cinebench reports all M1 CPUs as running at 3.2 GHz, if you dig deeper, you find that Geekbench reports the frequency at 3.22 GHz. And if you actually watch it during the benchmark runs, you find that the original M1 ran at a frequency of 3.204 GHz. The M1 Pro and M1 Max would run at 3.220 to 3.228 GHz. Now that difference seems almost insignificant until you do some calculations to find out that the new M1 Pro and M1 Max chips are running at a higher frequency that is 0.6 to 0.7% faster. That little higher frequency in the new M1 chips explains why I was underestimating the performance by that similar amount. Now that was during the single-core benchmark run. In multi-core benchmark runs, the original M1 would run at 2.988 GHz, while the M1 Pro and M1 Max chips ran at 3.036 GHz, which is 1.6% higher. So it's the higher frequency that explains why my estimate was 1.5% off on the 8-core and 1.7% off on the 10-core. For those who are curious, the efficiency cores in the new M1 Pro and M1 Max chips ran at an identical 2.064 GHz as the original M1. And in Geekbench, it's the higher frequency of the performance cores and the higher memory bandwidth of the new chips over the original M1 that explains the difference in the Geekbench 5 scores. I also wanted to look at the performance per watt of these new M1 chips and start the comparison against what AMD and Intel have to offer. While running Cinebench R23, I recorded the package power and then created this plot of Cinebench R23 multi-core score versus SoC package power. You can see that the original M1 with 8 cores is only using 15 watts, while the M1 Pro with 8 cores is using 23 watts. Again, this is the effect of swapping 2 efficiency cores with 2 performance cores. The 10-core version of the M1 Pro uses 33 watts, while the M1 Max with its 57 billion transistors uses 35 watts. You see a nice linear trend with the M1 chips where they are in that sweet spot for silicon efficiency. If you want to know what it looks like for an Intel CPU, check out my previous video, link above and below. As a comparison, the Ryzen 5 5600X is considered to be an efficient desktop CPU that performs very well. This 6-core processor is faster than the M1 Pro with 8 cores, but short of the M1 Pro with 10 cores. Compared to the 10-core, it uses about twice the amount of power. Now Apple does have the advantage since they are using the most advanced node in the world with TSMC's 5nm process, while AMD's 5600X is still using TSMC's 7nm process. In any case, you can see from a performance per watt perspective, Apple Silicon is clearly the leader with a massive margin. I'll be looking at Alder Lake soon to compare its performance and efficiency cores on a performance per watt basis, and these M1 numbers serve as a good reference. Now, I also benchmarked many other programs that are not yet Apple Silicon native, and they just don't serve as a good metric until I'm able to compare them with more Intel and AMD CPU-based systems. So I'll provide those comparisons in a future video. Apple's much anticipated M1 processor with more cores has shown to be a great performer, and in 1 year after introducing Apple Silicon, the new M1 chips outperform almost all Intel-based Macs, with the exception of a few Mac Pro examples that cost 3 to 5 times more. So we can look at what Apple has delivered 1 year later and say that it is amazing and insane. But is it? If I take a step back and look objectively at the CPU improvement over the past year, what did we get? We saw an improvement in the single-core frequency of up to 24 MHz and an all-core frequency improvement of 48 MHz. These numbers are so small that they are more likely an effect of a process improvement rather than a design target improvement. We did get more cores with the 10-core version, providing 4 additional performance cores while removing 2 efficiency cores from the M1. The 8-core variant adds 2 performance cores while removing 2 efficiency cores, and was a bit of a surprise as even Apple did not address this version at its October 18th event. Those additional performance cores enable it to offer performance better than most of all previous Macs and is very welcome. My concern comes with the pace of development. When I did my comparison to Intel and AMD CPUs, I showed how the 8-core M1 Pro is similar to the Ryzen 5 3600 from last generation and the 10th gen Intel 6-core in the i5-10600K. Likewise, the 10-core is similar to last generation CPUs from AMD in the Ryzen 7 3700X and Intel's i7-10700K. Those last-gen CPUs from AMD and Intel represented the state-of-the-art performance in mid-2020. Since Apple has released the original M1, both AMD and Intel have released their newer generation CPUs that have improved performance beyond the M1. And Intel has even released another generation in 12th Gen Alder Lake that really increases its lead over the M1. Looking at it another way, if I were to draw an analogy, what Apple has done with M1 to M1 Pro would be as if AMD had released a Ryzen 3 processor last year and then followed up with a Ryzen 5 and Ryzen 7 processors 1 year later. Or if Intel had released the i3 last year and then followed that up with the i5 and i7 processors 1 year later. They would be the same architecture with the same core, just more of them 1 year later. And it's that pace of development that is going to be a challenge for Apple. While they started out strong in the M1, traditional CPU makers are now on track to release CPUs every year to year and a half for the next several years, which will really put the pressure on Apple and their CPU development team. Let's hope they rise to the challenge. Next time, we'll look in depth at the different GPUs. Thank you all so very much for watching. Stay safe, and I will see you in the next one.